All right, in this video, I'm going to go over multiplying polynomials. And I'm going to show 3 different methods for organizing your work. I mean, they all end up with the same answer. It's just which method do you prefer for showing your work? Because these problems can get a little complicated just because there's a lot of multiplication going on. So the first method I want to talk about is one I affectionately call the rainbow method, but it's also known as the FOIL method. But FOIL, it's an abbreviation for front, outer, inner, last. Really only works if you have a 2-term polynomial, a binomial, multiplied by another binomial. So it really is pigeonholed into that kind of a thing. Here, although I've got a 2-term polynomial, a binomial, times a 3 terms. This one's got 3 terms, a 3-term trinomial. So I just like calling it the rainbow method. You can call it whatever you want. This is how it works. So the goal here for all of these methods is each term in this first set of parentheses has to get multiplied to every term over here in this set of parentheses. So the 2x needs to get multiplied to the x squared, the negative x, and the 5. So that's 3 multiplication problems. And the negative 3 also has to get multiplied to the x squared, the negative x, and the positive 5. That's 3 more multiplication problems. So this is 6 multiplication problems in one. That's why trying to make sure you have a way to keep your stuff organized is important. So what I'm going to do, I'm just literally going to draw little lines that connect the things that I'm multiplying. So my first one is 2x times x squared. So 2x times x squared, I'm going to multiply the coefficients. Those are the number parts of the terms together. So 2 times 1 is 2. And then I multiply the variable portions, the x times x squared. So x times x squared. Well, x squared is the same thing as x times x, right? That's what x squared means. So it's really x times x times x, so that's x to the 3rd power. So 2x times x squared is 2x to the 3rd power. All right, so now I've multiplied 2x to the first term over here. Now I'm going to multiply 2x to the second term. So 2x times a negative x is negative 2. X times x is x squared. Now we got to multiply 2x to the last term over here. 2x times 5. 2 times 5 is 10. So I have positive 10x. I put a plus sign right there. Okay, so this term is now done. I've multiplied it to all 3 terms over here. So I have to do the same thing with the negative 3. So negative 3 times x squared is negative 3x squared. Then I got to multiply the negative 3 to the negative x. Negative 3 times negative x is positive 3x. And negative 3 to the positive 5 is negative 15. And there's my answer so far. Whoops. There's my answer so far. I just need to simplify now, combine like terms and the like, but I am done with the multiplication aspect of this problem. So let's see. Let's combine any like terms that we have. So 2x cubed, there are no other terms that have a 2x cubed in it. So I'm just going to write 2, or to have an x cubed in it. 2x to the 3rd power. Okay, so that one's done. I'm going to put a little x underneath it because I've taken care of that one. I shouldn't do an x. That looks weird with the x in there. I'm just going to put a little dot underneath that little bracket so I know I've talked about him. Okay, negative 2x squared and negative 3x squared. They both have x squareds. Negative 2 minus 3 is negative 5x squared. Okay, I've talked about that one. Let's see, now we got x's, so positive 10x plus 3x, that's positive 13x, so I've taken care of those two. And last but not least, we have our negative 15. It's the only constant term, the only term without an x. And there we go, and that is our final answer right there. Okay, so that's using what's called the rainbow method, or FOIL method. I'm going to write that answer up here, so 2x to the 3rd. Actually, you know what I'm going to do? What I want to do is keep moving my pen's got a little button on it. It keeps wanting to move the screen around. I need to turn that off. Anyways, what I actually want to do, I want to copy this and that up there at the top. There we go. Okay, so I've got these answers right here written up there and the final answer written right there. Okay, so that was the rainbow method. Let's take a look at what's called the box method. So the box method, once again, is doing the same thing. It's just a different way of organizing your work. What I want to do with the box method is I'm going to create a grid to help me with all my work. So the way you just determine how big the grid or how big the box has to be is you look at your first polynomial right here. How many terms does it have? This one's got 2. Whoops. Sorry, I got it right in the right layer. This one has 2 terms in it. This one has 3 terms in it. So my grid has to be 2 by 3. Now I can make it a, 2 rows by 3 columns like so, or I can make it 3 rows by 2 columns. It doesn't matter which way you do it. Okay. I'm going to, let's do it. I don't know. Let's do it this way. Now I need to make it big enough so I can write inside each of those boxes. Okay, so don't want to make it too small. So here's my 2 rows and 3 columns, like so. Okay, so there's my grid. Now what I'm going to do is I'm going to write each of these 2 polynomials on the outside of this grid. And the way I'm going to do it is this side that has the 2 boxes, I'm going to write the binomial, the 2-term polynomial right here, outside those boxes with 1 term next to each square. So I'm going to put the 2x right here, and I'm going to put the minus 3 right there. And then on the side with 3, I'm going to put these 3 right here, x squared, a negative x, and a positive 5. Now if I had done it this way, it wouldn't matter. I would just put the x squared minus x plus 5 on this side, right? The x squared minus x plus 5 over here, and the 2x minus 3 right here. It doesn't matter which way you put it in, just as long as you have enough squares for each polynomial. If this had been ended up being a square instead of a rectangle, because they both have the same number of terms, it doesn't matter which one you put where. Just make sure you keep them together, like the 2x minus 3 I wanted to keep together. Okay, so here we go. So let's see how to do this. So I'm going to fill in these boxes, and the way I do that is to fill in this box right here, I look at the column header, x squared, and I look at the row header, 2x, and I multiply those 2 together. So 2x times x squared is 2x to the 3rd power. Then to fill in this box, I multiply negative x to 2x, and that gives me negative 2x squared. Then this box, I multiply the 2x and the 5 together, and I get positive 10x. Then down here, I multiply the negative 3 and the x squared together, and it gives me negative 3x squared. Then here, negative 3 times the negative x is positive 3x. And positive 5 times the negative 3 is negative 15. And those are going to be my terms for my answer. And you'll notice, I've even color-coded them for you. Those match exactly the same terms that we had before when we did the rainbow method. So you end up getting the same answer either way. So now I would look at these and say, okay, let's combine like terms. Well, 2x cubed, that's the only one I've got. So 2x cubed. Let's cross that one off because we took care of it. X squared, those 2 right there are both x squared. So negative 3 minus 2 is negative 5. X squared. So they're done. These 2 right here are both x's. So 3x plus 10x is positive 13x. And then we have our minus 15. And you'll notice the exact same answer as we got with the rainbow method. So that one works out really nice, especially when you're dealing with bigger things, like if you had like a 3-term polynomial, a trinomial, multiplied by another trinomial, or like a 4-term polynomial multiplied by a 5-term polynomial. The bigger these get, the nicer this box method is, just because it organizes your work so well. With the rainbow method, you have so many of these little lines up here, it can get kind of confusing, especially when you have multiplying at least like a 3-term polynomial to another 3-term polynomial. So it gets kind of messy. Okay, the last method I want to show you is called the distributive method, or distribute, distribute. And this one's kind of nice. I think this one seems a little bit more, mathematically oriented, or like makes mathematical sense to me, I guess. But what we're doing here is basically, instead of thinking of distributing the 2x to each of these, like I did with the rainbow method, and the negative 3 to each of these, what I'm going to do is I'm just going to distribute the 2x. I do that every time. I'm going to distribute the 2x to this entire thing, and I'm going to distribute the negative 3 to this entire thing. So what it's going to look like is this. So I'm going to take the 2x, and I'm going to distribute it to x squared minus x plus 5, like so. And then I'm going to distribute the negative 3 to the same thing, x squared minus x plus 5. So that was the first distribute right there. Distribute. So I distribute the 2x to that polynomial. I distribute the negative 3 to that polynomial. Okay. Now, I basically kind of do what the rainbow method was, is I'm just going to do it with the 2x. I'm going to multiply the 2x to each of these, and then I'm going to multiply the negative 3 to each of these. So the 2x gets multiplied to the x squared and becomes 2x to the third. The 2x gets multiplied to the negative x and becomes negative 2x squared. The 2x gets multiplied to the positive 5 and becomes positive 10x. The negative 3 gets multiplied to the x squared and becomes negative 3x squared. The negative 3 gets multiplied to the negative x and becomes positive 3x. And the negative 3 gets multiplied to the positive 5 and becomes negative 15. Once again, you'll see all those terms match what we had originally and match what we had with the box method. And of course, therefore, simplifying this is going to end up with the same answer. 2x to the third. Negative 2x squared minus 3x squared is negative 5x squared. 10x plus 3x is positive 13x. And then we have our negative 15. So those are three different methods for multiplying. I'm sure there's others. Those are the three that I'm aware of that I'm most familiar with. Depending on, yeah, so they both have they all have their pros and cons and whatnot, but that's more of a topic for another time when you deal with what's called factoring. Depending on how you factor polynomials or factor quadratics specifically, knowing like the different methods are for undoing that. Anyways, I'm kind of just talking. So pick a method. Doesn't matter which method you use. They all work. Just whichever one floats your boat and makes the most sense to you.